Over the past few days, we have learned how to place different kinds of fractions on a number line. Today, we're going to continue that work by thinking about fractions that are greater than 1 and how to place those fractions on a number line. Let's take a look at the problem of the day. How many wholes are represented on this number line, and how do you know? Say your answer out loud. That's right. There are 2 wholes represented. You know because you see 0, 1, and 2, which shows that we have 2 whole numbers. Smart mathematicians always label their wholes on the number line with a W or the word whole. Where are the wholes represented in this problem? Where are the wholes represented on this number line? Another way to think about it is what parts of the number line represent our whole numbers? That's right. On a number line, I know that the whole numbers are represented in the intervals or the spaces between the whole numbers. Where we write the number just marks the end point of where the whole stops. So you can see from 0 to 1 is one whole, and from 1 to 2 is another whole. Nice work. How did you partition your whole and why? Say your answer out loud. I heard you say that you partitioned each whole into fourths because in the problem, it tells us that Jesseline stopped at 3/4 and 7/4. I heard you say that that tells you that each whole has 4 parts because the denominator in these fractions is 4. Should my entire number line have 4 sections? Evaluate. I see some friends shaking their head yes, some friends shaking their head no. Say your answer out loud. Should my entire number line have only 4 sections? No, each whole must be partitioned into fourths because the denominator tells us the total number of parts in one whole. Notice how I made halves first and then partitioned those halves into fourths to make sure I have 1, 2, 3, 4 parts in each whole. We can figure out how many parts to partition each whole into by looking at the denominator and asking ourselves, how many parts are in one whole? What did you do next? Say your answer out loud. I heard you say that you labeled each endpoint on the number line, or the hash marks. What unit fraction should we count by, and why? Say your answer out loud. That's right. I heard you say that the unit fraction is 1/4. You know that the unit fraction is 1/4 because we partitioned each whole into 4 equal parts. Because in the story, she stops at 3/4 and 7/4. We remember that a unit fraction represents just one part out of the total number of parts in one whole. Okay, let's count by fourths. Count with me. 0/4, 1/4, 2/4, 3/4, Where are we pointing? That's right, I'm pointing at 1 whole. What fraction is represented at 1 whole? Oh, that's right. 4/4 is the same as 1 whole because that represents all the parts in 1 whole. Let's keep going. 5/4, 6/4, 7/4, 8/4. When we stopped at 2 wholes, what fraction did we say? That's right. 8/4 is the same as 2 wholes. So our number 9 is labeled. What do we do now? Remember to go back to the big question. I heard you say that we placed a point at 3/4, which we can label with an S because that's where she stopped to tie her shoelaces. And we placed a point at 7/4, which we can label with a P because that's when she stopped to switch playlists on her phone. Nice work. Today we learned that fractions can be equal to and in between whole numbers like points S and P from our number line. Remind me, how can we identify fractions that are equal to 1 whole or greater than 1 on our number line? That's right. Today, as we identify fractions that are equal to and in between whole numbers on our number line, we must first think how many wholes are represented on this number line and what whole does my number line start with. Then we can use the denominator to help us think how many equal parts are there in 1 whole. Finally, we can count by the unit fraction to label each endpoint. Keep these thinking steps in mind as you move into the try one more.